Don't you think we're done? Don't you think we're done? Don't you think we're done? Knew that it was true from the way you looked at me. At me. Don't know what to do, what to say to make you leave with me. Make me feel alive.
Hello everyone and welcome back. In this lecture we're going to talk about a very important Java topic, which is inheritance. So I'm going to start by creating a new class. Until now we've created classes in the same file. Now we're going to create classes in separate files, which is what you usually do when you make real life projects. So you should expand your Java project file and go under source file and create a new class. I'm gonna call this class factory. Now, just because we've created this class, we can go in our application class and create a factory object. I will say factory1. This is how I'm gonna name it. I'm gonna say new factory. So we've just created a new object. And now I'm gonna go in our factory class and give this class few methods. I'm gonna say public void design. Here I'm gonna say sysout control space design the car, and then I'm gonna add another method. Here I'm gonna say public void build and sysout build the car. So in my application class I can call my methods. I can say factory1.design and factory1.build. Now our sysout statements will be displayed in the console. As you can see, design the car and build the car. So you need to have a good understanding of creating and calling methods before you move to inheritance. Now we're gonna create another class and we'll call it car. I'm gonna go to our source file, go to class and type here car. And I can make a reference to a new object of car class. I'm gonna say car1 equals to new car. And if we go to our car class, we don't have any methods yet. But if we do this, car1 dot, you can see that we actually can call some methods, and these methods are parts of the object class. And this class is the ultimate ancestor of all classes in Java. But if I go to our car class and I say here car extends factory, what I mean by extend is that car now is a subclass of factory and factory is a superclass of car. So now car class inherits everything from factory class. So at the moment car class is identical to our factory class. Just by mentioning here that car extends factory or car is a factory, in our car class now we have all the factory methods. So now we can go in our application class and say car1.design and car1 dot build. So now we have access to the methods in our factory class. So if we run this, design the car and build the car will be again displayed in the console. But we can go to our car class and add other methods, of course. So here I'm gonna say public void, let's say brand, and I'm gonna say sysout, let's say Tesla. And now I can go in my application class and say car1.brand. So now we have methods in our car class that we don't have in our factory class. And this is very useful because if you don't have the source code of a class, you can only extend it and add your own code as well. So basically you can extend any class except final classes. An example of final classes is a string class, so you cannot extend the string class. With an exception of final classes, you can extend basically any class. So now that you have an idea of inheritance, we're gonna go through access modifiers. There are four access modifiers. There is public, then there is protected, then there is default, and this one is a little bit tricky because it has a name, but it occurs when there is no access modifier. So let's say here lack of access modifier. And an example of this could be this method. If we delete public and just say void brand, this is the case when the method has a default modifier. I'm going to put it back to public. And lastly, there is private. So public access modifier means that you can access these methods from any class, anywhere, regardless of whether the classes are or aren't in the same package. Whilst the keyword protected, if we say for example here protected, it means that this method can be accessed from this class, from other classes in the same package, but if the class is in the different package from where you're trying to access this method, that class has to extend the class that this method is in it. So for example, we need to extend the car class because this method belongs to the car class. So in order to access a protected method, you need to extend the car class. So only the subclasses from different packages can access protected methods. Now moving on to default or lack of access modifier. So a method with default modifier would look like this. And you can call this method only from the same class or the classes that are in the same package. So if a class is not in the same package as the car class, you cannot access this method regardless of whether it is a subclass or not. So a method with a default access modifier can be called only within the same class or the classes within the same package. Whilst private access modifier is very simple and very straightforward, you can call a method with a private access modifier only within the same class. You cannot call a private method, even if that class is a subclass of the class that the method belongs in. So private modifier is pretty straightforward and very simple. The same as public one, which can be accessed from everywhere. So you should focus on learning these two a little bit more because they are more tricky, because public and private are pretty straightforward. So that's it for this lecture. We're gonna use inheritance and access modifiers throughout the course, so I'm sure that you gradually understand them. For the moment, you can exercise with source code in the resources section. So I will see you in the next lecture. everyone and welcome back. In this lecture, we're going to talk about an object-oriented concept in Java, which is polymorphism. Polymorphism is a Greek word which means many shapes, and in this lecture, we're going to explain what it really means in Java. So we're going to go ahead and create a new class. I'm going to call it vehicle. And we're going to create a subclass of vehicle. And we're going to call it car. So we're going to make vehicle superclass of car. So Eclipse will fill our extends keyword for us. Public class car extends vehicle. So we have a subclass and the superclass of the car class. So in our app class, I'm going to create a new instance of our vehicle class. Let's call it vehicle1 equals new vehicle. And another instance of car class. And what polymorphism means in a nutshell is that if you have a subclass of a superclass, you could always use the subclass where you would normally use the superclass. For example, if we create here another instance of vehicle, let's say vehicle2, if we want, we can make this reference point to this reference. And that is because this reference is pointing to an object of type vehicle. And we're making our new reference point to the same object that our old reference was pointing at. And now we have two references pointing at the same object because it's actually only one object that we created right here. But because of polymorphism, since car is a subclass of vehicle, I'm guaranteed that whenever I have a vehicle, I can use a car. So here I can also say car. And this is polymorphism in action. And now let's give vehicle a method. I'm gonna say here public void, let's say design. Because every vehicle can have a design. And I'm gonna say here sysout. And here I'm gonna say vehicle design. And now I'm gonna go in our car class and I'm gonna override this method. I'm gonna go to source, override. And here I'm gonna say car design. So right here I have a reference that's pointing to a car, which is kind of vehicle, right? Because car is subclass of vehicle, therefore it is a vehicle. So if we say right here vehicle2.design, can you guess which method will be called? The one in the superclass or the one in the subclass? The important thing right here is that this vehicle is pointing to a car object. So because this vehicle reference is pointing to a car object, therefore it's going to use the method in the car class. So if I click run here, it's going to say car design. So what really matters when you call a method in polymorphism is not the type of the reference that you use. It's actually the object which that reference is pointing at. So the type of the reference right here is vehicle, but the actual object is car. So the method that's going to run is from the car class. And now if we go and add a method in our car class, and I'm gonna say here riding the car. And now if we go in our main class and say here car.ride, of course this is going to call my new method in car class, and it's gonna say riding the car. But if, for example, we say vehicle2.ride, this is gonna cause me an error. And if you see the error, it says the method ride is undefined for the type vehicle. And if we looked at the autocomplete, you could see that there is no ride method that you could call. So the important thing that you have to understand here is that when you call a method, it's the actual type of the method that decides which methods you can call. But when you actually call the method, it's the object of that reference that decides which method is going to be called. So it's the object that's going to run the relevant code. So another case that you could use polymorphism can be, for example, if we make a new method right here. Let's say we're going to name it create design. And we're going to pass an argument of type vehicle. So as long as this argument is of type vehicle, I can definitely call a design method right here. And right here I can call our new method, and I can pass here a car reference. Because polymorphism guarantees me that wherever a superclass is expected, I can pass in a subclass instead. So therefore, car is a subclass of vehicle, which means a car extends vehicle. Therefore, I can pass a car reference wherever a vehicle reference is expected. So if we run this, it's gonna say car design down here. If you look at polymorphism, you can actually understand how references work versus how objects work, so I think it's a very enlightening topic. You can find this code in the resources section to exercise by yourself, and I'm gonna see you in the next lecture. about encapsulation. Encapsulation will really help you understand better the usage of Java access modifiers, public, protected, and private. So we'll start by creating a car class right here. Now usually your class will have some methods and some instance variables, and you usually want to make your instance variables private. So the idea of encapsulation is to really protect the essence of the inner working of this class. So you want to keep your instance members private, and you expose only the getters and setters of this instance member, which you can create by going to source and generate getters and setters. So people outside of the class can get the data of this private instance by this getType method and can set it by this setType method. So getters and setters let you access this otherwise private data. But if you would like to make your variable public, you could use constant variables which are final, and you won't be able to change them outside of this class. Let's say speed equals 250. So many times you'll have methods that are not supposed to be edited outside of this class, and you'll have to encapsulate them or protect them by using encapsulation. So another example could be a method that calculates revenue. And let's say here return 12,000, for example. And you wouldn't like other classes or people to play with this sensitive data, and you can provide only a get method, for example, get revenue data. For example, revenue plus calculate revenue. And let's just return this. So therefore people will not be able to set or change your revenue data. So the idea is to make everything private. If you can make it private, make it private. If you want your subclasses to use that kind of data, make it protected. If you want your end user to use your data and change it, so then make it public. And another advantage of encapsulation is that it prevents your classes from being tight coupled. And by tight coupled, we mean that your classes are calling each other's stuff all the time. And that can make a chaos. So in other words, you prevent cross-linkages in your project. You don't want one class to get into other class's stuff and use it. So you only want to have few public methods that are clearly documented and do not change that often. And the rest of the stuff should be kept within the class, or otherwise should be kept private. So that is what we use encapsulation for, and I hope this lecture helps you understand it better. So that's it for this lecture, and I'm gonna see you in the next lecture.
enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. 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 May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love.
I'll be your anything if you be the one to take me home. 'Cause right now everything makes me wanna leave this place and roam. Make me feel alive. Take my hand and run, let me be the one. Let's just take a dive. Nights when we begun, don't you think we're done? Don't you think we're done?
Need a while.
Don't you think?
Hello everyone and welcome back. In this lecture we're going to talk about casting. As we've seen in previous lectures, Java has a bunch of numerical types. We've seen int values which hold 32 bits. There is a short value of int as well which holds 16 bits. we do have byte type. So byte can store from -128 to 127. And there is also a long type. Which can hold a really long number. And of course we've got floating point values, which are float and double. A small thing that you should notice right here is that whenever you type a decimal number, it has by default a double type. So when I try to assign a decimal number to a float value, I get an error right here which says type mismatch, cannot convert from double to float. And what you can do to fix it is to add F at the end of the number and explicitly state that it is a float value. If you want to see the maximum value or the minimum value of each of these types, you can call, for example, its maximum value or minimum value, but you should make the first letter capital. So I'm gonna make a sysout on this so you can understand it better. And I'm gonna run this, and you can see that byte value can hold only 127. So this is its maximum value. So if you have one numerical value and you want to store it to another type of numerical value, you can use casting. For example, if I say here int value equals to long value, I'm gonna get an error right here which says cannot convert from long to int. So what I should do instead is open the brackets and type int. So I'm explicitly stating that I want an int value. And if I create a sysout right here, and I put here int value and I run this, I can see that I still have the right value printed in here because this value fits comfortably in an int. You can also cast from floating point values to integer values. For example, int value equals float value. And without the explicit cast, of course, this is not going to happen. So we have to type here int. However, if we print this, we can see that we are losing everything that we have after our decimal point. So there's no rounding up, everything after decimal point is chopped off. So you could have complications in these cases, and casting is a way of saying that I really want to do this and I want to chop off the value after the decimal point. But if you do the other way around, for example, if you have here double or float and you want to assign an int to it, and you know that double or float has enough memory to fit an int long, short, or byte, then you don't need a cast. Casting is only needed when you want to assign values that has bigger memory to values that has a smaller memory, because the values will often be chopped off and Java wants to make sure that you know what you're doing. So you have to be careful with casting, because when you cast or when you type this, you're explicitly doing something that could go wrong. So you have to think before you do it. Otherwise, you'll have very weird results. And as you may have noticed, these are all numerical types. If you want to cast a string, for example, casting a string to an int or int to a string won't work. If you want to convert an integer to a string, you have to use toString. And if you want to convert from string to an integer, you have to use integer.parseInt. So that's it for this tutorial, and I'll see you in the next one. Hello and welcome back. In this lecture, we're going to talk about interfaces. So there's a lot to say about interfaces, and we're just going to get started here on this lecture. I'm going to start by creating a new class, and I'm going to call it computer. I'm going to create another class, and this class will be called vehicle. I'm going to give computer a method. For example, let's say computer class has a public void start method. So here I'm trying to make a minimal scenario to demonstrate interfaces usage. I'm gonna add a sysout statement. Sysout control space. Here I'm gonna say computer started. And to make it more realistic, I'm gonna give computer a private field. Let's say private int serial number equals to, I'm just gonna give it a random number. And I'm gonna go to the vehicle class, and I'm gonna give vehicle a method, a field, and in addition I'm gonna add the constructor as well. So let's say vehicle has public void drive, for example, and let's give it a simple sysout statement. Let's say driving the vehicle, and I'm gonna add a field, a private field, private string type, and I'm gonna add the constructor as well by right-clicking in the class right here and going to source, generate constructor using fields. Make sure to check the fields that you want to use. So here it is generated a super statement which calls the superclass constructor, but we won't use it in this example, so we're gonna get rid of it. And of course we can use the classes we've created, so we're gonna go in our application class and say computer, for example computer1 equals new computer, and here I'm gonna call the method from the computer class, which is start. However, the other methods are from the object class, which is the parent of our classes. So here I'm gonna call the start method, which is a method I defined for the computer class. And I'm gonna create another instance of vehicle class. Let's say vehicle1 equals new vehicle. And vehicle has this constructor which you have to pass in the type, which I've just defined in the vehicle class. So let's say the type of the vehicle is a car, and here I'm gonna say vehicle1 dot drive, for example. Let's add the semicolon in here. So the point right here is that computer and vehicle are two completely different arbitrary objects which has nothing in common. So for some reason I've decided that computer and vehicle has nothing to do with each other. They're not the same kind of thing. They don't have a common parent class or anything like that, but I've decided that they should both have the same method, that is display information. So in this case, Java gives me the mechanism to formalize that. And that's a case where you can use interfaces for. Therefore, to create a new interface, I'm gonna go on my project that I'm working on and I'm gonna click new. But instead of creating a new class, now I'm gonna create a new interface. And creating an interface is pretty much the same as creating a new class. All I should do is give it a name with an uppercase letter, for example, information, and click finish. And in our interface, I'm gonna create our method, public void display information. And I'm not going to pass any parameters to this method, even thought I could do. And what's more important, I'm not going to add a body to the method, so there won't be any curly braces. So I defined my display information method, and now what I can do with it is go to the computer class and say right here, computer implements information. And if I do this without doing anything else, I'm gonna get an error, which says the type computer must implement their inherited abstract method display information, which means we have to add unimplemented methods, which we could type by hand as well, of course. And here we have our overridden method. This annotation override is just to make sure that this method is actually overridden from our information interface. It is optional, we're just gonna delete it in this case, and we're gonna delete this comment as well. So basically what implements information does is it forces us to implement each abstract method that is in our interface. Each method header that is in this interface must be implemented in our computer class. In this case, we only have display information, so we have implemented that. And here I'm gonna add a body. Let's make this display information do something. Here I'm gonna say sysout, control space. Let's say computer serial number is plus serial number. And we can do the same with vehicle as well. We can say vehicle implements information. And we're gonna add the unimplemented methods. Let's take rid of this comment, and here I'm gonna say vehicle type is, and let's just output the type here. And I'm gonna leave the override annotation there. As I said, it is optional, so it's your choice whether you want to leave it or not. So an interface is kind of a textual contract where you have the interface with any number of methods with different parameters, different return types. And when you say, for example, implement specific interface, you actually have to implement all those methods that you have specified on that particular interface. And you can implement any number of interfaces that you want, and you have to separate them with a comma. So here you can add another interface, which you first have to define it, of course. And in addition to implements keyword, you can also extend another class, as you have seen in previous lectures. So you can have extend, let's say computer, and implements information or any other interface as well. Don't forget that the class can only extend one class, whereas it can implement any number of interfaces. And whenever you have a class, you can use an interface instead, with one exception. You cannot use the name of an interface where you have the new keyword. So you cannot instantiate interfaces. Other than that, you can have, for example, here the name of an interface, or anywhere else where you'd expect a class's name. And let's see an example of that. For example, here I can say information, info equals new computer. And the reason that I can do this is that computer implements information. And here I can call the method I've defined in the interface. Like display information. And another thing I can do is information info1 equals vehicle1. And the reason I'm allowed to do this is that vehicle1 is a variable that points to an object which is of vehicle class. And vehicle class again implements information interface. And what I'm saying here, in other words, would be make info1 variable point at whatever vehicle1 is pointing at, which is a object of vehicle type. And here I'm gonna say info1 display information. And now we're gonna run this. And this last one is showing the vehicle type, which we've specified right here in this vehicle constructor. And another example where you can use interfaces is, for example, I'll show it right here. Let's make another method. I'm gonna say private static void. Let's say show information. And as a parameter, I'm gonna pass in the interface that we've created, which is information. And I'm gonna give it a name, let's say info. And here I'm gonna say info.display information. I'm doing this because at the moment we only have this method, but of course you could add any number of methods as you'd like. And now I'm gonna call this method show information, and I can pass in any object that implements information interface. We can say here computer1, or we can say show information vehicle1, which outputs the same information as these two. To make it more clear, I'm gonna add here a blank sysout statement, and I'm gonna run it. And as you can see, here pops up again the computer serial number and vehicle type. So we're producing these lines by calling this show information method and passing in different objects from different classes. So this is it for this lecture. We're going to use interfaces again when we're going to explain the Java collections. You're going to see other examples where you're going to use interfaces, but for now you have this code in the resources section to practice on your own, and I'll see you in the next lecture.
lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause what can we feel? But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause what can we feel? But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause what can we feel? But for now, I won't give it all away, 'cause I don't think I'll stay. lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just.
I'll be your anything if you be the one to take me home. 'Cause right now everything makes me wanna leave this place and roam. Make me feel alive.
Hello and welcome back. In this tutorial we're gonna talk about anonymous classes. So anonymous classes are basically a way of either extending a class or implementing an interface in such a way that you can do it kind of a one-time thing, as you'll see in the examples that we will use in this lecture. So let's start by creating here a class which will act as a parent class. I'm gonna call it computer. Let's give it a random method in here. Let's say public void shutdown. And I'm gonna add a sysout statement that says computer is shutting down. So I've created just a simple class with a single method. And here I'm going to create an object of that class. I'm going to say computer1 equals new computer. And of course I can run the shutdown method by saying computer1 dot shutdown. And if I run this, of course it's gonna say computer is shutting down. And now the way that anonymous classes work, for example, let's say I want to override this shutdown method in a computer class. And the normal way to do it is, of course, for example, creating another class, let's say MacBook, and extending computer class and then overriding the shutdown method. But I can also do it, for example, by opening curly parentheses in here. And this is a bit of a surprise for people who have not seen anonymous classes before, I think. And within the curly braces, I can override the methods in computer class. And the annotation to make sure that the method is overridden, as we've seen in the previous lectures, is at override. And here we're going to override the public void shutdown method. And here I can add another implementation. For example, let's say MacBook is shutting down. And now if we save this and run it, it's gonna say MacBook is shutting down because we are overriding the shutdown method in our parent class. So this might be a bit confusing because you may ask, what class is this if it's not the computer class? Because it takes two classes, the superclass and the child class or the subclass, to override a method. And the class of this variable or the type of this variable is computer. However, the object that the computer1 is pointing at is some kind of subclass of computer class which doesn't have a name. Therefore, it's called anonymous class. And with anonymous classes, there is no way that you can create a new object of that class. But this comes very handy if you want to use a different subclass from an existing class. You can use anonymous class syntax like this. Another example of anonymous classes could be, for example, if we create here an interface, let's say phone. And I'm gonna give it a method, public void, for example, call. And as we've mentioned in the previous lecture, the method in the interface won't take curly braces at the end, so we're just gonna leave a semicolon in here. And to implement this interface, normally I would create a class that implements phone, and I would be forced to implement the call method. But another way to do this could be using anonymous classes syntax. I'm gonna create here phone. Let's say phone1 equals to new phone. Now if we leave this like this, it ain't gonna work because it's gonna say cannot instantiate the type phone. And again, we mentioned in the previous lecture that interfaces cannot be instantiated. And instantiate basically means create a new object from the interface phone in this case. And you can't instantiate the interfaces because there is no code in the methods that you could put into the objects. So this statement in itself is not legal unless I add the curly braces and add an anonymous class. And the easiest way to add unimplemented methods of an interface is by clicking this arrow right here and clicking add unimplemented methods. So again, you'll see the at override annotation, which makes sure that the call method is actually overridden from phone interface. And we're gonna get rid of it as it is optional. We're gonna get rid of this comment as well. I'm gonna add a sysout statement in this overridden method, and I'm gonna say just simply calling. And I'm gonna use this phone variable, phone1, to call the overridden method of the anonymous class that we've created, which actually implements the phone interface. And again, if I say this and run it, it's gonna add calling, which is outputted due to this call. So for now, that's it for anonymous classes. You will find the code in the resources section to practice on your own. You're still gonna see anonymous classes examples in future lectures, and I'm sure you're gonna gradually understand it, because it might be a confusing topic for beginners in Java. So I'll see you then. Hello everyone and welcome back. In this lecture I'm going to show you the simplest possible way to read a file line by line in Java. But in future lectures I'm gonna dive deeper into a more complex and maybe more flexible way of doing this. So to start off, we're gonna need a file to read. The first thing that you have to do is locate the file in your disk. I've created just a simple file with random text on it, and I've put it in a random folder. So here is my random file. It just has a random text on it. So to tell Java where it should read it from, you have to right click on the file and go to Properties on Windows, and you have to copy the location path. And I'm gonna get back to Eclipse. I'm gonna create a string variable. I'm gonna call it my file, and I'm gonna set it equal to the file path, followed by the name of the file, which is test.txt. And at this step, you may have a problem on Windows, because backslashes on Java are special characters. And to fix this, you can either make it a double backslash or make it a forward slash. In our case, I'm gonna make it a double backslash. And that will fix this problem. And moving to the next step, we should create a file object. So here I'll name it file, new file, and I'll pass the name of the string variable that we've just created, which is my file. And here we should import the file class. Or you can just type Ctrl-Shift-O and it will do the same. And now that we have our file object, we're going to use the scanner class to read this file. So here I'm going to say scanner, let's say text new scanner, and here I'm gonna pass the file object, which is file, and I have to import the scanner class as well. But as you can see, Java is still complaining, and it says that this statement must have a throws declaration, or you should surround it with try and catch. Now, I could surround it with try and catch, and in the try statement, you try to read the file, and if the file is not found, you can add here a sysout statement and print whichever message you would like. For example, you can say file not found plus file, but since we've not gone through exceptions yet, which we will do in the next lecture, I'm just gonna add the throws declaration, which will be simpler for you to understand. So I'm just gonna go and add the throws declaration. This will fix the problem. So what this throws file not found exception does is that if the file is not found, the program will end and will throw an exception. For example, if we change the name of the file and we click run, you can see here that an exception is thrown, which is file not found exception. I'm gonna change it back. And one thing you should remember is that whenever you open the scanner, you must remember to close it. So here I'm gonna say text close. And this will close the underlying file on your system. And now we're gonna read this file line by line. You can also read data from your file using a variety of methods from the scanner object. If I type here text.next, you can see that you can read integers, double, you can read all kinds of things on your file. But what I'm gonna do here at the moment is just have a loop that is gonna read the whole file line by line. So here I'm gonna add the while loop, and I'm gonna say next dot has next line. Here I'm gonna add curly braces, and I'm gonna say string, let's call it line, equals to text dot next line. Oops, I should change this to text as well. And right here we're gonna add a sysout statement to output the lines. We're gonna check that our file actually can be read. I'm gonna say sysout control space line, and I'm gonna run this. And you can see in my console the content of my file. Now another case would be if you would like to use other methods of scanner class, and let's say you want to read integers. I'm gonna add a number from my file. So if you first want to read the number and then you want to have a for loop to read the other lines. So let's suppose you want to read this number. What you should do is, here you should say int, for example, value equals to text dot next int. And then you should add the sysout statement. And for example, we'll say value is, and here I'm gonna add value. And then if we run it, you can see that the value is read and is printed on the top of the content. And there is something else that I would like to add to this lecture. Sometimes you want to put a file in your actual project, so you may not want to use the path to locate the file. Instead, what you should do is take the file and just drag it to your project. Click OK. And here, instead of the whole path, you should only specify the name of the file. And this will work the same as it did before. So if, for example, we add another line here just to see if this works. And run the project, you can see here that in the console is printed the line that we've just added. So that means the file is read properly. Okay, so that's it for this lecture. And as usual, this code is in the resources section for you to practice on your own. And stay tuned, because in the upcoming lectures you're gonna learn how to handle exceptions. So I'll see you then.